Namaste students. Today's concept, computational thinking for grade 8. The chapter 1, a square and a cube, part 2. The question is, a class teacher wrote the following pattern on the board, where an expression is written after the equal sign in each row. She then asked the class to find the expression for 13 cube minus 12 cube. Okay, let's find the pattern first. Here we have 2 cube minus 1 cube, and I see 2 times 1 here. 3 cube minus 2 cube, I see 3 times 2 here. 4 cube minus 3 cube, I see 4 times 3 here. And these ones are in common. At the same time, these threes are also in common. So let's note down the same 1 as it is, plus and here times 3. So here the two numbers are gonna be the first number, that is 13 cube, so we consider 13, minus 12 cube, so the second number is gonna be 12. So it is 13 times 12. Great. So the number according to the pattern is 1 plus 13 times 12 times 3. And the question is, which digit appears the highest number of times? Which digit appears the highest number of times? In that case, I see 1, 1, 1. 1 appears 3 times. Then 3 appears 2 times. So here 1 and here 1. 2 appears 1 time. So the highest number appears highest times is 1. Great. Let's move on to the next question. XYZ is a 3-digit number such that it is the square of a multiple of 5. Okay, let's note down the multiple of 5. It's 5, 10, 15, 20, 25. It just goes on. So squares of these numbers, square of 5, it's going to be 25. Square of 10, it's going to be 100. Square root of 25 is that, 15 is that 225. And this is going to be 400. And this is going to be 625 if I'm not wrong. Great. Okay. So the question is, what will be the highest possible remainder? Highest possible remainder when the number is divided by 100. Obviously, this gonna give me remainder 0. This remainder 0 as quotient gonna be 4. Okay. And all other numbers ending with 5s, that is 25. Here it's 225. Here it is 625. When you divide these numbers, obviously it's gonna be 25. As we have two zeros, 2 digit would be the remainder. In that case, I go with option D. Great. And the next question is, fill in the grid with squares and cubes of digits 2 to 5. So let's make a note of 2 square and cube, which is 4 and 8. 3 square is 9 and 16. No, not 16. It's actually 27. And 4's, it's 16 and 64. 5, that's 25 and 125. Yeah, okay. So each square and cube number appears twice in the grid. Okay, both square and cube of same number cannot appear in the same row and column. Okay, same numbers do not appear diagonally. Okay, let's fill the given grid with these numbers. Let's first start with 2. As it's mentioned, the same row and column cannot have the squares and cubes of same number. Here I see 4, which is 2 square. So this row is blocked for 2, this column is blocked for 2, and 8 is here. So this row and the column is blocked for squares and cubes of 2. There are 2 remaining squares. Okay, let me fill 4 here. It's not possible as there is diagonally a 4. According to the given statement, same numbers do not appear diagonally. Okay, in that case, let's replace this with 8, and here let me fill 4. Okay, so squares and cubes of 2 is done. Coming to the next number, let's move on to the 3. Okay, square of 3 is 9, cube is 27. Let's mark 27 here. So this row and column is blocked for 3 squares or 3 cube. And 64, okay, 27 is done, 9 is here. So the row and the column is blocked for 3 square and cube. Coming to the next point, 2 squares are left, 2 boxes are left. So here, is that okay if I fill 9? And here I will fill 27. Okay, diagonally there is no 9, and even here there is no 27. Okay, so we are done with 6 boxes, no, 4 boxes, another 4 more boxes left. Let's check with 4 squares and cubes, 16 and 64. Okay, 64 is here, so this row is blocked for another 16 or 64. This column is blocked. 16 is here, so this row and column is blocked. We have 2 more squares where one of them can be filled with 16 and the other one with 64. Is there any 64 around? No. Okay, so the last final 2 squares are left. Let's go with this. I put 5 here. Oh no, 25. Okay, 25 here and 125 here. It's not possible as 25 is diagonal to the other 25, another 25 here. So let's replace this 25 with 125 and this square with 25. I guess the grid is complete. The next part of the question is, what is the maximum possible sum that can be obtained by the cells present in the configuration of shape A? Okay, in this shape. We'll just, since they have asked for maximum, let's find the combination of maximum, the largest numbers. Okay, in that case, this is 27, 27, 125, 9. Okay, let me make a note of the same. In that pattern, what we have is 27, 125, and 9. And here I have 8, 64, 125, 8, 64, 125, 8, 64, 125. Okay, or we can go with 125, 4, 64. That will be the highest because we have 125 with all these 3 combinations. All others are okay. Here we have another one, 125, 8, 25. As you see, 125, 8, and 25. Believe that will be smaller than all other combinations. Here we have 25, 4, 64, 8, 64, 125, 27, 125, 9. So this is the smallest. Let me erase that. And comparatively here, 8, 64, 125 is the largest. Here we have 4 This is 4 less than the other one. And here it's 27 and 9. So this will be the largest number. Let's count and check what are we gonna get. Like 125, 64 and 8. Is that 7, 9, 1? Where is that? Option A. Great. Okay, it took some time, but I guess you understood the concept. Let's move on to the next question. The image below shows logic machine where numbers move from column to column through the tunnel. Okay, where they change in different way each time. What would be the sum of A, B and C? Okay, it's the same, A, B and C. Okay, A is here. Let's check the pattern. Oh, it's so easy. I found the pattern. Here it's 4, but they have given 15 here, which means 4 times 4 is 16, 1 less than that. Okay, 22 into 22. I guess 1 less than that. 484 minus 1. Coming to the next, 11 times 11, which gives me 121 minus 1. That's your. Okay, this is 22 into 22, not 24. Okay. And here 7. So 7 times 7, which is 49, but 1 less than that, gonna be 48. The value of A is 48. And column 3, we have 6, 15, and 3. How did we get this? What's the logic? Okay, here, 5 plus 1 is 6. 4 plus 8 is 12. 12 plus 3 is 15. Okay, sum of the digits. Sum of the digits. Yeah, it's here we have 1 plus 2, 3. 3 plus 0 is 3 again. So 4 plus 8, I mark it as 12. Done. Okay, here it is 6 and 2 and 6. I believe it's 6 cube. Yeah, 15 cube and 3 cube. Obviously, this gonna be 1, 7, 2, 8, 12 cube. So let's put them together. I go with the largest number, then the next number, and the next number. So it's 18, 8, 7, 1. You're right. It's gonna be option D. Moving to the next question. Every column follows certain rule. What number should come in place of question mark? Let's understand the pattern. Here it is 12 plus 2 is 14. 14 plus 6 is 20. Then 20 plus what should it be? Oh, no way. Here it's 12. And 27 is that 3 times 4 is 12. 3 times 9. Here it is 5 times 5. 4 times 4. 5 times 5. 4 times 4. 3 times 4. 3 times 9. 7 times 4. 7 times 1. And here we have 4 times 4. 3 times 3. This is 4 times 3. This is 7 times 2. And this is 4 times 5. Okay, I don't get any pattern here. Wait a minute. It's 4 times 4, 3 times 3. This is 4 and 3. I guess I have the answer. 16. Square root of 16 is 4. And the square root of 9 is 3. So 4 times 3 is 12. Great. This is square root of this is 4. Square root of this is 3. So multiplying these two, we have 12. Great. Then we have no idea about square root of 28 and square root of 7. But let me check this way. Square root of 28 times 7 can be written as 2 times 2 times 7. into this 7 as it is. So by grouping it, I have 2 times 7, which is 14. Yeah, I got the trick. So the trick is square root of first number times the second number. That's 25 times 16. Square root of 25 is 5. Square root of 16 is 4. And the final answer is 20. Great. In that case, square root of 12 times 27. So let me factorize this. This is going to be 2 times 2 times 3. On the other end, I have 3 times 3 times 3. So by grouping it, I have 2, 3, 3, which is 2 times 3 times 3. 3 times 3 is 9. 9 times 2 is 18. Great. And if you find any other pattern, please comment your answer. Thank you. Let's move on to the next question. Yeah, boxes are stacked in 4 columns. Each box is labeled with number 1, 2, 3, with labels on some of the boxes already shown in the image given below. Okay, thank you. No two adjacent boxes in the same column are labeled with the same number. Okay, I guess the yellows are the same. No two adjacent boxes in the same column. Okay, so 3 is already taken here. I won't think so. We will be able to write 3 as adjacent boxes cannot be labeled the same. Okay, done. Two adjacent columns have the same number on the topmost box. Okay, no two adjacent. Since here it is 2, we won't be able to write 2 on this, as the topmost boxes or the cubes of adjacent columns cannot have same numbers. For every column, the sum of the number labeled on the topmost and the bottommost block is equal. Okay, so the topmost and the bottommost, you add up, it should be the same in all cases. Great. In the shaded box, which of the numbers will occur highest number of times? Shaded box, I mean to say this purple boxes. Okay, let's check what's here. First of all, I can't fill this with 2, so let me go with 3 then. It's not adjacent, obviously. Okay, and the topmost and the bottommost, top and the bottom should be equal. In that case, if this is 3, okay, here already 2 is here. So let me take 2 here and 3 here. So that 2 plus 3 is 5. And 3 plus 2 is again 5. Okay, no two adjacent boxes in the same column are labeled with same number. 1, 2, here I can't write 3. So is that okay if I say 2? Yeah, great. Okay, that this box is filled. And here obviously this should be 2, so that 3 plus 2 is 5. In that case, here I give 2 and here I give 3. So 2 plus 3 is 5. Then I write 1 here and 1 here. Okay, it's done. Let us cross check the conditions given here if they satisfy the given conditions. Okay, each box labeled with 1, 2 and 3. Okay, some boxes already shown in the image. Okay, no two adjacent boxes in the same column are labeled with same number. They are just talking about adjacent boxes. So after 2 it's 1 and 3. After 3 it's 2, 1, 2. So 2, 3, 3, 1, 2. So they are not adjacent. The same number is nothing like 3, 3 or 2, 2 or 1, 1. Nowhere it is. Okay. No two adjacent columns have the same number on topmost box. Okay, adjacent. They are again mentioned it as adjacent columns. This is 3. The adjacent to is 2. Adjacent to this is again it's 3. It's 2. Okay. Okay. For every column, the sum of the numbers labeled on the topmost and bottommost is equal. The top is 2, bottom is 3 in the first column, so it is 5. Here it is 5, and here it is 5, and here it is 5. Okay, I guess the conditions are done. But the answer is that gonna be A, B, C, or D? It's up to you. You comment the answer. Thank you.